So here is the part 2 for the high WLAN reliability, hot standby backup. On a WLAN, an access controller can manage a server hundred of access points. If the AC becomes faulty, the service of all the APs that associate with the current AC will be interrupted. So the reliability of the AC is crucial to the high availability of the network. So the cards here describe the technology and typical configuration of hot standby backup. Okay, for short we call it as a HSB. Understand some of the principle for the HSB. The difference between the three backup modes. Describe the application scenario of the HSB. And the last one, you have some example configuration. Okay, and here is the content. So we start from the overview of HSB. The concept. The AC HSB mechanism ensures that service are smoothly switched to the backup device when the master device is full. The HSB solution provides two backup modes based on the different networking. So the HSB supports master backup mode, so it will be same as the previous one, and also supported the load balancing mode. So the first one is the master and backup mode. So they're using this technology called VRRP. Okay, the VRRP over here is called Virtual Router Redundancy Protocol. Okay, for short we call it as a VRRP. So this technology allows the multiple equipment to share the same virtual IP. So for all the terminal, they no need to point to the different gateway in this case. So what they need is just point to the same gateway. So right here you can see the AC one is as the master. All the traffic is going to connect to the AC number 1, no matter is the AC1, the AP1 or the AP2. So in between the AC1 and 2, they're running the HSB channel because they want to collect all the information that anything they send to the AC1. So when the first AC1, they previously is the master, is already filled. So they can't able to form the CAPWAP tunnel with the AP and the AP2 anymore. So we don't need to worry because the VRRP allow the AC1 and AC number 2, they share the same virtual IP address. So even the first one is already lost the connection. We don't need to change anything on the AP and also the terminal side. So they'll automatically form back the CAPWAP tunnel with the second AC automatically. And all the information previously stored inside the AC1, you will also share with the AC number 2. So right now the AC2 will turn from the backup mode into the master. So this is the technology for VRRP. And the next one, for the load balancing mode, is using the dual link backup. So the dual link backup, I already showed you on the previous slide how they do that. So they actually can perform the multiple management system by the different AC. So the AC1 can manage AP1, AC2 manage only AP2. And no need to worry about the AC1. If the AC1 fail in sudden, so the AP1 will still connected to the AC2 because AC2 is the backup to the AP1. This is the result after the failover. So you can see right now the connection, they form back the CAPWAP tunnel. So the red color dot is referred to the CAPWAP tunnel from the AP1 to the AC. Okay, and the green one is for the AP2. Principle of the HSB. This is the technology VRRP. So as you can see, they have two AP. So they just name it to the router A and also the router B. So the router A will using the IP address of 10.1.1.251. So the router B is using 10.1.1.252. So both of them have the different priority here. Router A going to use 100. For the B, we're going to use 200. So to the VRRP technology, the default priority is always 100. The highest value that we set to the priority will be the highest preferred. So at the middle, you can able to see, right, they have one virtual router, and this virtual router is going to use the 10.1.1.254. So this is just a virtual router, and it doesn't access in the network. It's just a virtual device. So we're going to use this virtual IP address. Okay, the 10.1.1.254. This is the virtual IP address. So later on, we're going to assign this IP address into both AP. It's the router 1 A and also router B. To the PC client, we need to point the client to the router gateway. Like example, router A we're using 251 and router B we're using 252. If previously everyone point to the router A and the gateway address is 251, what happened when the router failed? When the router A failed, then I have to go back to every single the PC and change the gateway to the router B. It's so troublesome. So to prevent this happen, I would like to using the VRRP technology. So of course, for the router A and the router B, will have its own physical IP address. But at the same time, they will share the same virtual IP. So all the PC clients here, they only need to configure the gateway and point to the 10.1.1.254. Because this IP address, that after we enable the VRRP, it will appear and show to every single PC who is this, which router is using this virtual IP. So right now, the router B have the highest priority, so it becomes the master in the network. So here is the HSB system. So it's included in the HSB service module and the group module. So for the service channel module, it's only used to establish and maintain the backup channel, to notify the associated service module and a channel whether it's right now is connect or disconnect. Then the next one, they have a background group. So for this one, it's responsible for the HSB service negotiation. So related to the previous HSB service. Okay, they do the negotiation, the backup, real-time backup, and the status information synchronization. So it instructs the association service module to the backup service information. So this stands for the service backup group. And the last one is the service module. It responds to the HSB event of the service backup group. It can process the batch backup, real-time backup, and the status synchronization. So it's sent to the service backup group. But for this service module, right, is some of the parameter and the configuration we need to do it over here. So after we done on the service module, we're going to bind this one into the group. The service for the HSB. It's service establish HSB channel for transmitting packet of other service and maintain the tunnel status by notifying the HSB group of the faulty tunnel. So it can be able to provide the following function. Establish the HSB channel, maintaining the tunnel status of the HSB channel. Okay, for the data synchronization, so the mode R support the batch backup. after we enable the HSB, the master device that has operated for a while synchronize all the session entry to the newly added backup device at one time. Okay, this is happening to the batch backup. For the real-time backup, they're doing the same as the batch backup, but they can able to synchronize in real time. So when the master device generates the new session entry, or maybe modify some of the existing session entry, you synchronize to the backup device in the real time. And the last one is the periodic backup. So the backup device check whether the session entry are the same as those on the master device for every 30 minutes. So when the session entry are inconsistent, so the session entry on the master device are updated to the backup. So this periodic backup, right, they're doing a different rule. So they're going to check on its own session table all the configuration every 30 minutes. If all the configuration and the session inside the master or maybe the active device is still the same, remain the same, then nothing changed at all. So you're not going to update. Only when they have any changer, so you're going to send the update to inform the rest of the connected device. VRRP, HSB. So currently AC using one management VRRP group to maintain the master backup status of the entire system and do not support the loop balancing. So this is happening to the VRRP. When we're using this kind of the hot standby backup, basically they don't support the loop balancing. Okay, so we only can make one become the active and another AC become the standby. VRRP based HSB has the following characteristic. The uplink backup each other and the VRRP group can track status of the uplink. The status of an AC may be different from its downlink status because for the VRRP they prefer playing a different rule on the uplink and also the downlink. Okay, they have a different parameter for the configuration. Multiple downlink. So actually it's refer those of the wire network or maybe wireless network using the MSTP to prevent the loop. When we forming the redundant, we need to using some of the layer 2 protocol to prevent the loop happening. Because when you're forming the redundant network design, high chance they'll generate the loop. So try to take note and make sure the STP is enabled. So when the MSTP status change, the MAC or ARP table of the downlink are automatically cleared. The last one, design user entry backup. CAPWAP tunnels and the AP entry need to be backup. A dual link HSB. So they have some of the following features. It can receive and send only the backup service data. It is happening to the dual link HSB. So when compared with the VRRP, this dual link HSB support the loop balancing. So this is an advantage for the dual link HSB. Dual link HSB support the data forwarding across the layer 3 network. So therefore, they support 2 AC using the routing protocol. This is server processing using the VRRP HSB. So in this network, they have the remote authentication server. So we also can call it as a radio server. And also it includes a portal server and the DHCP server. So in the VRRP HSB, the master backup AC can advertise a virtual IP or the virtual MAC address to the server. Only one AC using the VIP. Okay, this VIP is not stand for the very important person. Okay, it is referred to the virtual IP over here. to interact with the server at any time. So master backup AC switchover are not present to the server. So this is considered is one of the disadvantages over here. All the server will not going to connect with two AC at the same time, because when you're running the VRRP, these two AC will going to share the same virtual IP. So when the authentication server, like what it lists on the top there, they got the radius, porter, and also the DHCP server. They only recognize the master AC, because only the master AC will on the virtual IP. For the standby, they do nothing on the virtual IP. Only when the active AC is in the down state. Okay, so it's already failed. So this VIP, the virtual IP, will be used by the standby AC. So this is happening for the dual-link HSB. Inside the load balancing mode, processing is different among server. So they show you two different status. The uplink connected and another is the uplink interrupt. So the DHCP server associated with the relay agent of the AC. Therefore, we do not need to perform any other configuration on the DHCP server. You may be using this on the HSB, we don't need to do anything on the DHCP server. Okay, the backup NAS, IP address, and session ID need to be incorporated in the building and authentication packet. Okay, this one is used for the radius and the portal server. Okay, they provide a different rule when compared for the DHCP server over here. So when AC is up, the COADM packet need to be processed and synchronized to the peer. The master AC need to send the authentication information to the AP. So this when uplink is connected. What happens when the AC is down? Means the uplink right now they can't able to connect to the radius and the portal server. So a loopback interface that use the same IP address as the master AC on the backup AC need to be configured. Route to the loopback interface must not be advertised but import to the IGP. So actually right here they try to mention some the routing protocol. The IGP is the internal use routing protocol, can be the OSPF or maybe RIP. So we can actually configure it. If example, the AC number 1, we're using the loopback address 1.1.1.1 and send to the AC number 2. The AC number 2 we also can assign the same loopback IP address as the AC number 1. But to prevent the IP confusing in the network, so they're using the import. Only the main AC. Right now my AC1 is the active AC. So I'm going to using my AC1 right to advertise using the IGP. Example, right now I'm using the OSPF. So the AC we're going to using the OSPF to advertise the loopback address 1.1.1.1. Same happened to the AC number 2. For the AC number 2, we're not using the normal advertise in the OSPF. We're trying to use the import route command and try to import this route into the IGP. I try to import, example, the loopback into the OSPF. Whenever they try to import in the different routing protocol, it have the highest preferred value. So this kind of value, when the highest one, right, will become the backup link only. So the AC2 will not going to use this loopback until the AC1 in the down state. So this is some of the explanation over here. So the last one is the re-authentication process. Is a process in which the user log in again.